you have from the yesterday's class? Hi students, any questions do you have from the last class? Kandikupa Venkatesh Ramana Srika, please mute your mic. Can you see the OneNote page?
Yes, sir, we can see.
Okay, so we start then. Okay, so in the last class where I stopped. Because in the last class I could not explain all these things by writing, I only read this page. So I am asking again, any questions do you have? Okay, then I start writing. So this was done. Now the next we are doing the properties of probability. So properties of probability we are doing. That means we are taking actually, what does it mean? We are taking this thing omega. So this is the probability space. Then there was A. So this is a sigma algebra or sigma field. So can you see this OneNote page, all of you? So this is actually a collection of events. Okay. And then there was P. So P is the probability. So when we say probability space, means all three comes. So this is a function from the set of events, that is from A to real valued function. Okay. So what are the properties of this function? Can anyone tell me? Because we define this from what is the definition of this function? Can anyone tell me? Okay, so first of all, this is the full set. So full set is 1 probability. That means the set contains all possible outcomes, so it has probability 1. Now PA, if you take any event, its probability will be either greater than 0. It may have some probability or may not have some probability. If it has some probability that it is greater than 0, it has no chance then it is equal to 0. It cannot be negative. Okay, and if n are mutually disjoint events, then this probability of union AN is a countable infinite union is equal to summation PAN. Okay, so only thing is intent is that these ANs are mutually disjoint. So do you know what does it mean by mutually disjoint? Any one of you know? So AN intersection AN is empty set if provided N not equal to. So this is the definition of probability. So this is just a function which is real valued function. The set of all outcomes is events. The set of all outcomes has probability 1. Each event has probability either 0 if it has no chance, if it is have some chance it is greater than 0, and if these ANs are mutually disjoint events, then union of PAN has probability equal to summation PAN, where summation varies from n equal to 1 to infinity. Okay, now some properties we saw. We saw some examples. I'm not going to the examples now. Ananya Das, your mic is on. Please off it. Okay, now we derive actually some properties which it can derive from the definition. Ananya Das, your mic is on. Please mute it. Okay, so properties, which properties we saw before, we derived these properties. First of all, PA union B equal to PA plus PB minus PA intersection B. So if you have any questions from about any of these properties, then please let me know. PA complement equal to this follows because A complement and A are mutually disjoint events. And from this we can say P of the empty set, there is nothing, is 0. And if A and B are two events, then B is greater or equal to PA. One minus P union AN n equal to 1 to infinity is equal to P intersection AN complement n equal to 1 to infinity, and then comes PA union B is equal to PA. So these properties we saw in the last class. Now next, if we generalize this, up to E we saw in the last class. If we generalize this, the last property will get summation. Okay, P A1 union AN is less equal to summation PAN. Can anyone tell me how to prove this? Anyone? How does it look? Okay, it's better that this. Can anyone tell me how to prove this?
So what is meant by generalize?
Generalize means we have this statement that P A union B is less equal to P A plus P B. This is a statement for only two events, A and B. Now, instead of these two events, if we take n number of events, we will get this statement. Is it okay, Ananya?
Yes, sir.
Okay, now can you tell me or anyone how to prove this? These are very easy things. See, I am pretty sure you all can prove all these things. So, can you prove this thing? So, there is something called induction, mathematical induction. Do you know that thing? Mathematical induction?
Yes, sir.
Okay. So, we let B equal to A1 union A n minus 1. Okay, by induction hypothesis, so mathematical induction says that we assume the result for n minus 1, then we will show the result is true for n, and the result is obviously true for 1. So by induction hypothesis, we assume P of A1 union A n minus 1 is less equal to summation PAI I equal to 1 to n minus 1. So this is our hypothesis, induction hypothesis. This is true for n minus 1. We will prove for n. Okay, so P A1 union A n is equal to P B union A n. Now this is by E. This equal to PB plus PAN. This is by E. And now PV is less equal to summation P of AI I equal to 1 to n minus 1 plus
Excuse me, sir.
PAN. Yes, madam. Huh.
Can you explain induction hypothesis again? What is it?
Okay, so I'm just doing this, then I will explain. Okay, so this induction hypothesis is not important in your course, but this is very much important in mathematics, or maybe in any scientific experiment or any scientific course. This is important. So induction hypothesis is that, so this course, no, it will be in the, you are taking this course, discrete mathematics, are you taking this course? Probably not. There it will be defined. So induction means, so Pn, be a statement involving a natural number n. Okay. So I hope all of you know what is natural number. So natural number starts from 1, goes up to 1, 2, dot, dot, 1, 2, 3, 4, 100, 1000, this way. So involving a natural number n. So a statement, like what is a statement? Like, so suppose this thing, this is one statement, okay? This equal to, this is one statement. But problem is how to prove this. This is one such statement. How to prove this? So this is we have to prove for all in. Okay. We have to prove this for all natural number in. But we can prove for 2 easily, you can prove for 3 easily, but how can we prove like for 100? We have to do the same thing for 100 times. That is not possible. So what we will do, there is something, this is called induction hypothesis, which says that prove P1 is true. Like in this case, what is P1? P1 says that PA1 is equal to PA1. Okay, so first prove that P1 is true, then assume Pn minus 1 is true. This thing you have to assume. Okay, this is you are not proving. That is, in this case, assume union of Pi I1 to n minus 1 less equal to summation P of Ai and assuming this, then prove, assuming this, just we have done, then prove that Pn is true. If you can do this, that gives Pn is true for all n. Pn is true for all natural number n. Okay. Any questions or anything about this? Okay. Now, so the proof is complete. I hope there is no other questions. Now the next thing is G property. That what do you know about what is the A property? That P A1 union A2 is PA1 plus PA2 minus PA1 intersection A2. Right? So in the previous property, if you see that we are saying that this thing is less equal to this, but we are not giving any proper equality. We are giving inequality, but we want to give the exact equality. For this, if you take two events, we have PA1 union A2 equal to PA1 plus PA2 minus PA1 intersection A2. So this is true when the number of events is 2. What can you say about the when the number of events is n? Any guess? When the number of events is n, what can you give such type of equality? That is the question.
Yes, sir.
Okay.
Yes,
So
sir.
is
what
that
is-
about principle of inclusion and exclusion?
Okay, so can you tell me what is that?
So I don't exactly remember the statement, but general formula goes as the summation of AI minus summation of AI intersection AJ with minus, and like that we create a sequence till n.
Like very good. So have you read this before? Means I don't know means how much have you read about probability? That's why I'm asking.
Sir, very basic ones in high school, sir, for JEE especially.
Okay.
Yes, sir.
So okay, have you know? Do you know how to derive these formulas? Have you learned that? Means
No,
whatever.
sir, we have just
No,
applied. We have
sir.
just applied. We
Okay,
haven't learned the
so
proof.
if this is true for two, right? This is true for two events. So two number of events is two. Now we shall do for number of events is three. Okay, so take A1 union A2 union A3. We will derive something like what you said, something like this. We shall try to derive this. How to proceed? Please tell me, suggest me something. How to proceed? We know this formula, this exact equality. So we have to use this equality and how to proceed.
Take
Split it
A2
into two.
union A3 as one event and apply the same formula.
Yes, sir.
Right.
Yes,
So
sir.
A you are saying, so A equal to A1 union A2. Okay. So this will be PA union A3, which will be PA plus PA3 minus PA intersection A3. And what is PA? PA is PA1 union A2 plus PA3 minus PA intersection A3. And what is PA1 union A2? This is equal to PA1 plus PA2 minus PA1 intersection A2 plus PA3 minus PA intersection A3. Okay, so only thing we have to compute is PA intersection A3. Now let's see what we can do with this. So A intersection A3 is equal to what? A1 union A2 intersection A3, and this is you know how to write this thing. A1 union A2 intersection A3. How to write this? How to break this? You know in set theory. So this is A1 intersection A3.
Union A2 intersection A3.
Very good. So union A2 intersection A3. So PA intersection A3, we said again use the first equality, this one. We should use this. So this will be PA1 intersection A3 plus PA2 intersection A3 minus PA1 intersection A3 intersection A2 intersection A3. Okay, so this will be PA1 intersection A3 plus S3 equal to, what happens? When I stopped. Any participant? Yes, Ananya, do you have any questions?
Sir, no, I want to tell the formula for n events.
Okay, that's good. Okay, you will tell me after I write this. Now, can everyone see the OneNote page? I hope so.
Yes, sir.
Yes, sir.
Okay, so this is S3 equal to PA1 intersection A2 intersection A3. So P of A1 union A2 union A3 we write as, you can see, S1 minus S2 plus S3. Is this okay? So now tell me how to write the union of AN. So we write this R equal to 1 to N. So how to write this? Anyone wants to tell?
Yes, sir.
Okay, just one thing. Just one thing. Just Dharavat, Hansika, Priya, can't you see this? Is it not visible to you? Because this is visible to everyone else.
Sir, now it's visible, sir.
Okay, fine.
Sir, did you stop presenting now?
Huh?
Did you stop presenting?
No, I'm presenting.
I don't see your presentation, sir, right now.
Is it true for everyone else or only
No, sir.
Rohit Shetty?
Friends can see. We can see
No,
it.
No, sir, it is visible.
Okay, fine. So yeah,
Sir,
then
the board has freeze.
sorry.
Sir, the board has frozen.
Sir is not typing, I guess.
I'm not typing. I'm not typing. Yes. So, so tell me, what is the formula now? What is the equality you want? Who want to say? Aranya, you tell me.
So yes,
Yes, tell me.
P union P of union summation I to I1 to n AI equals to summation P AI I1 to n minus summation IJ P AI intersection AJ IJ1 to n I less than j plus
Okay, I understand. So I'm writing in little bit with some notations. Okay, so let HR. Okay, the same thing what you are saying, I am just writing using some notations because then it will be easy to write. So SR is summation P AI1, okay, intersection AI2 intersection up to AIR, and here 1 is equal to I1 less equal to IR less equal to less than IR. So this is, so no two of I1, I2, IR are same. Everyone is different from other. And you are taking such that I1 is less than I2 is less than I3 up to less than IR. Okay. So this is denoted by SR. Now we write this is as minus 1 power R minus 1 SR, where R is equal to 1 to N. Okay, so this can be proved by induction. So I'm leaving this for you to prove, because you have seen how to prove for induction. So this is one home task. Some problem will be given, some assignment will be given to you too. So this is one home task. Okay, any questions? Okay, if you have no questions, then we go to the next. Okay, there is one problem, one example, or one exercise we will do on this particular formula. But before going to that problem, we will do one more theorem I will state. Kandip Kupar Venkateramana Srikar, you can't see. What is your problem, Venkateramana Srikar? Okay, fine. Okay, so we shall just state some theorem or some result, but we will not prove this. And what I have heard that this will not be that important in this course, but these are really important probably from mathematical viewpoint. These are really important result, but maybe in statistics or probability these are not that important. So let A and B events. So every time we're talking about events means we are not mentioning that the set of outcomes, these we are not mentioning. We are just saying that means these are event means there is some set of outcomes, some collection, sigma algebra of events and some probability. Okay. We are just assuming all these things. Not every time we will write all these notations. So this is called continuity theorem. Why this is called continuity, you will understand if I write the statement. And A equal to, so all these are A1 is subset of A2, A2 is subset of A3, all this is going in this ascending order, and ultimately we will get the union A. Then P of A equal to, can you assume this result or can you guess the result? So this is continuity result. This is said to be continuity result. And A1 subset of A2 subset of A3, this way goes on. And one is the previous thing is subset of the next thing. And A is the union of A. Then what will be the PA?
1.
No. This is like
P of
continuity.
an.
So some variables are going near a point. These variables are going near a point. So if this is a continuity theorem, so because this is continuity theorem, so this limit should be Pn where n goes to infinity. Okay, this is called, that's why this is called continuity theorem. Okay, and one can prove this thing. There is no connection with the continuity you have read or you will read in analysis. There is no connection with this, but because this looks like the continuity of a function at some point, that's why we say that this is the continuity theorem. And there is the opposite direction if we go. And A is equal to intersection of all An. Then then again this is because this is also one continuity type result. So this will follow. So I am saying again there is no connection of this with the continuity of analysis, only because this looks like a continuous function at the point A. So we say these are continuity theorems. Okay, and we are not proving these things. Now we shall go to the next example or exercise. Suppose in letters are put in envelopes distinct by addresses what is the probability that no letter will reach the correct address? What is the limiting probability as n goes to infinity? So these n numbers are specified. Limiting probability okay, think about this problem and tell me what would be the result or how we can approach this. Yes, tell me how we can approach.
Sir, n minus 1 by n.
N minus 1 by n only? No. How can you say n minus 1 by n? Okay, so how many ways you can put in letters in envelopes? How many ways? First tell me how many ways you can put in letters in envelopes. Yes?
Sir, n factorial.
N factorial. Very good. So factorial n or n factorial is the number of total outcomes, right? Now we have to find that particular outcome, that particular event that no letter will reach the correct address. Like, so this is the first thing. So this is first envelope, this second envelope, and you put 2 here, 1 here. This is one example, right? That the correct the letter will not put in the correct envelope. Okay, so oh, someone has asked here. Just 1 second. I don't know. Okay, so this is one such event. Okay, can you so how to approach this? Any idea? Please tell me. Any whatever idea comes to your mind, please tell me.
Sir, the numerator will be the derangement and the denominator will be n factorial, I think.
Denominator will be n factorial. That's true. That is the total number of outcomes. Okay. What will be the event, which will be the numerator? What is the number of events?
So we can use the derived formula which we derived last for the union of multiple events
Very
to
good. So
find the derangement value.
Very good. So what is AI here? So we need P of E1 into AN. So what is AI here? Very good.
So
So what
it
is
comes out something like n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus.
Okay, so I write
Yes,
okay, I write AI is the event which is that ith letter go to the correct address, or will be put to the in the correct envelope. Okay. That means the ith letter will be put in the correct envelope. We are assuming that if we put in the correct envelope, then it will reach the correct address. So, if we take the union n, now take the complement of this. This is what? This is this is the event that no letter will reach the correct address. Is it okay? Then please tell me if this is okay to all of you. So A1 union means at least one letter will reach the correct address. So its complement is no letter will reach the correct address. So probability that of the event that no letter will reach the correct address equal to 1 minus P A1 union AN. So this much you are very much correct up to this much. Now we have to use the derived formula. So what is PA1 union AN? This is summation minus 1 power r minus 1 SR. R is equal to 1 to n, where S R is this P of these events. Okay, not this event, sorry, just one mistake. This is P of A I1 intersection PI2. Yes, sir.
A1 is for what? For at least one.
I am showing you. So 1 is equal to I1 less than IR is equal to N. So A1 or AI is that the event that the I letter will go to the correct address. Okay. So its union means at least one letter will go to the correct address. So we want the complement of that, which will be no letter will go to the correct address. Okay. So now so this is 1 minus PA1 union AN, and PA1 union AN equal to summation r equal to 1 to n minus 1 power r minus 1 into SR, where SR is this. So now tell me what is the SR? You know this. What is the SR? Okay, so what is, so you tell me now what is this? Okay, tell me what is AI1 intersection AIR. What is the probability of this? So
This will be 1 by r factorial, maybe.
No, not exactly like that, but okay, I think quite correct. Not exactly, but correct. Okay, this is close to that. So what is this? This is the number of AI1 events in intersection AIR by the total thing, like n factorial, by the total outcome. Okay. Now, what is the number of elements in AI1 intersection AI2 intersection AIR?
Only one case.
1.
1.
Is it so? Okay, take this.
N minus R factorial.
Very good, very good. Okay, so yeah, so just showing this. So suppose this is 1, 2, 3. So this is the first envelope, second envelope, third envelope. Suppose I1 equal to 1. So we put this here. Okay, and I2 equal to suppose 2. Another envelope is there. 4. So you put here. So how many possible ways you can put in these two? So this because AI1 intersection AIR means in the envelopes IU1, I2, IR, you have put the correct letter. Okay, the correct letter you have put in AI1, AI2, AIR. But in the other letters, you can put in any way. Like here, you have put the first letter in envelope number 1, you have put the second letter in envelope number 2. But in 3, 4, you can put any way. This 3, 4 letter you can put in 3, 4 envelope anyway. So there are two things, 3, 4 and 4, 3. Okay, two ways you can do this. So this will be n minus r factorial by n factorial. Okay, so in the other thing you can put in n minus r factorial because if once you put one thing, you can one letter, you cannot put that same letter to some other envelope. Number one, and this order doesn't matter here. You can means anyway you can order. First put the 3. Yeah. So 3, 4, or yeah, sorry, order matters. Sorry, order matters. So only that once you put 3, then you cannot put the third letter to some other envelope. So it is n minus r factorial. Is it okay?
Yes, sir.
And how many elements would be like this? How many elements will be in of this formula AI1, I2, IR, N? So number of elements, so number of this type of AI1 intersection AIR is, can anyone tell me?
NCR.
NCR or NPR? Just
Sir, NCR only, right?
Sir, NCR only.
The relative order
Sure.
will not matter if we choose a collection. We'll be counting the same collection multiple times if we use NPR.
Right, very good. Sorry. So it is AI1 is NCR, right? So SR is NCR into n minus r factorial by n factorial. Is it okay? And that will be 1 by r factorial. Is this okay to all of you? I hope so. So P of A1 union An is equal to summation minus 1 power r minus 1 r equal to 1 to n SR. This is minus 1 power r minus 1 r equal to 1 to n 1 by r factorial. So that probability, so 1 minus P A1 union AN is, you can do this, means I am doing it a little bit fast here, but you can check minus r is equal to 1 to n minus 1 power r 1 by r factorial. Okay, any questions here? Okay, now if n goes to infinity, this will be r is equal to 0 to, this will go to r is equal to 0 to infinity minus 1 power r 1 by r factorial, and we know what is this. This is e power minus 1 by e. Okay. Now we go to the next example. So a box has 10 balls. Six are black, and 4 are white. Find the probability that a fourth ball removed from the box is white. Okay, sorry, there is something else I forgot to write. Just 1 second. Just see from the book. Three balls are removed from the box. Find the probability that a fourth ball removed from the box is white. The fourth ball removed from the box is white. Yeah, so how to do this? Okay, so there are three possibilities, right? Three balls removed at the beginning, 3 balls removed. So there are three events. So okay, 4 events. So 3 white ball and 0 black ball, 2 white ball, 1 black ball, 1 white ball, 2 black ball, and okay, I should have done the other way because that way I have written. So 0 white ball and 3 black ball. So what is the probability that the probability of first three balls are white and fourth ball is also white? Tell me the probability of this.
One by 7.
Only 1 by 7?
1 by 120.
3
So
by
how-
10 into 1 by 7.
3 by 10. So okay. So
1 by 120.
so how many ways we can choose 3 balls from 10 balls? 3 white balls from 10 balls. So this is
So all the white balls are identical and all the black balls are identical, right?
Right, all the other thing, there is no other way to distinguish.
Yes, sir. So 3 by 10 will be the probability to pick one white ball from 10 black ball, 10
So
balls total.
I am writing this. Is this okay? Then 4, then 1 by 7 choose 1. Is this the one you are thinking? 4 choose 3 by 10 choose 3. So the way that probability of choosing 3 balls at the beginning is 4 choose 3 by 10 choose 3. First 3 balls are white. Then only one remaining. Then there will be only one remaining white ball. So 1 by 7 choose 1. Is it okay? Is 4 by 10 factorial by 3 factorial 7 factorial into 7. So 7, 8, 9, 7, 8, 9, 10. So now 3, 4, it will be 2, 2 with 3, 3, 3. So I get 1 by 210. Is this okay? So probability of first 3 balls are white is 4 choose 3 by 10 choose 3. Is that correct? And then the probability the fourth ball is also white is 1 by 7 choose 1. So 1 means here is 1 or yeah. So 1 means here 1 choose 1.
So 1 by 30.
By 30.
Yes.
1 by
Why?
30 is for, sir, he is telling for 3 balls.
Sorry,
He is
sir.
not
Sorry,
in.
sir. Sorry, sir. Sorry, sir.
So is this okay that 1 by 210?
Yes, 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 yes.
Yes, sir.
Yes,
This is
sorry, sir.
correct.
This is
So
correct. Sorry.
now you can tell me what is this, that 2 balls are white and 1 ball is black. So first 3 balls, 2 balls is white, 1 ball is black. Then you have to choose 1 white ball, right? So this will be again 6 choose 1 into 4 choose 2 by 10 choose 3. And if it is 2 white ball we have taken, so that means after that there will be only 2 white balls remaining. So it will be 2 choose 1 by 7 choose 1. Okay.
अरे यार
Anurag Bharti, please mute your mic. Okay, any other questions? Okay, now the next question is, yes, sir.
Sir, hello. Sir, these balls are drawn simultaneously or one by one?
No, 1 by 1 means one you take, then put somewhere else, then take the second one.
Okay, sir.
Okay, now.
Sir, if the balls are drawn one by one, then we have to multiply probability of each event one by one. But you took the probability of 2 balls picking at a single time.
So these things are decision given, right? 3 white ball and 1 0 black ball, 2 white ball, 1 black ball, 1 white ball, 2 black balls. All these events are decision events. So I have taken, okay, after this I have to take the probability of all these things because these are decision balls. Is it correct? You take all these events.
That wasn't I was asking. Like we have to draw every ball one by one, right? So it will be in sequence, like one white ball, then white balls and black balls. No. You are
No,
right.
no.
I'm sorry.
It means 10 balls, it means the 3 balls you can choose anyway. It may be a white ball or black ball, that doesn't matter.
Okay, sir. Understood.
Now find the probability. Okay, each case, if you find something confusing, always ask me. Okay, don't hesitate to ask. Find the probability that all three of the removed balls will be black. So today I shall take another 5-10 minutes because yesterday I couldn't take. There was some interruption during the class. So another 5-10 minutes I will take today. So all three of the removed balls will be black. If it is known that or at least one of the removed ball is black. So if it is known that at least one of the removed balls is black, find the probability that all the removed balls will be black. So this is regarding the first case that we removed 3 balls. Okay. So what is the number of events that at least one of the removed balls is black? Of the first 3 removed balls, the number at least one of the removed balls is black. What is the number of event?
Sir, is this a continuation to the previous one? Like the fourth ball removed is white.
Yeah, so the continuation of the previous one, only the 4th ball removed is white is not taking. Only about the first 3 balls removing.
Okay, sir.
So number of events that at least one of the removed ball is black.
Sir, 10C3 minus 4C3.
Okay, can you first tell me what is the number of events? 6 choose 1, 4 choose 2,
पापा से ना 50 रुपए के लिए झगड़ा करती है
6 choose 2, 8 choose 1,
thinking how
6
lucky I
choose
am.
3.
Like she fights for us. हम भी कल रात को यही सोच रहे थे कि मेरा पत्ता टूट गया उसमें 5 जो भी लगेगा उसके कुछ लेकिन पापा वो भी किसके लिए
Okay, so is this okay? This is the number of events at least one of the removed ball is black. Is this okay? That we there are 3 possibilities, 3 events, mutually distinct event. The first one ball is black is this 6 choose 1 into 4 choose 2. 2 balls is black is 6 choose 2 into 4 choose 1, and 3 balls are black is 6 choose 3. This is the number of events. And what is the number of events that all 3 balls are black? Okay, can you tell me what is the number of events that all 3 balls are black?
63.
6 choose 3. Okay. So what is the probability that all of the 3 removed balls will be black if it is known that at least one of the removed balls is black? So this probability, so this is something that we are going to define now. This probability will be 6 choose 3 by 6 choose 1 into 4 choose 2. So this CVS is the probability that all are black balls, and the below is the number of events that at least one ball is black. So this is the probability, okay? So this is called conditional probability. So this says B is the event, all the event that all balls are black. And A is the event that at least one of the ball is black. So in any classes there, you guys are writing something. What is this, Prince Raj? That at least one ball is black. So the problem is to determine conditional probability. We have to determine. I just write this and define conditional probability, then I will stop. Determine conditional probability. That the event B occurs given that the event A occurs. So here, just I write this. So definition.
Sir, can we
Bye
leave?
bye. Tata. Goodbye.
Sorry?
Gaya.
Sir, can we leave?
Just
We
give
have
me
a
your
class
two.
from. Sir, we have a class from 2 o'clock.
Just write. Let me write this definition, then I will stop. Just this definition. So let A and B be two events such that P of A greater than 0. Additional conditional probability of B given A which is denoted by PBA is by definition P A intersection B by PA. So A is A event is given, then what is the probability that B event will occur? So if PA is 0, then PB by A is not defined. Sorry, B condition A is not defined. Okay, you can leave. You may leave now if you want, and if you have any question, then please ask me. Any questions you have? Okay, then we'll stop for today.